Today we're going to see this model that you see on the screen and how do we actually generate the bone graft model from this. So we're starting with a physical system and then we want to end up with a bone graft model that would actually could be entered to do a computer simulation. So what I want to explore are the steps on building this. Here, the first step that we have, I would say you just put it number one. We need to recognize where the elements that we have. Okay. All right, so let's do that. In here, we're gonna recognize these elements that we have on the left-hand side. You see here is the bumper, and it has a stiffness and damping here. Here's the vehicle, has this mass M. This is the person, has lowercase m. And here would be the seat belt where the shoulder strap with K and B. And if you have two of them, we'll assume that they are the same type of seat belts. So those are the elements in here. In terms of the bone graft notation, what kind of elements these are? You know, like this one would be a C element. So I'm just gonna maybe write down here in parentheses. This B, this would be an R element over here. This M is in reality a I element. We need to do a bit of the contrast here to be able to see it. So why don't we put it here, I element, like that. And then on the other ones we can use this color. This would be a C element here. This, of course, an R element. And then you have the little M. This would be an I element. The wall here, because we do the simulation where the car contacts the wall, this would be a source of flow with velocity 0. So let's just, perhaps I think it might not be a bad idea to make an assumption, make a drawing of the assumption that we make that we're analyzing the system when it's in contact with the wall. So this would be a source of flow with velocity equals to 0, see? That's what that represents. So we have done the recognition of the elements. And then what we need to do in step number 2 would be, step number 2 says that you have to use a one junction to represent the distinct velocities. Okay. Now there's the distinct velocity. And then let's give room for number 3, which will come in a little bit. Number 3. Okay. So we're going to start over here in this case. You see, you could say, well, car is going this way, so I'm just gonna say this is x1, and this of course is also moving this way with x2. Those two are very important. This is x1. Yeah, x1 dot really, because is the velocity. So what I would do is I just go, okay, this is my one junction that represents the x2 dot, and then I have this other one that represents the v, the velocity. This would be x1 dot, right? x1 dot, like this. And then we have the velocity of the wall, which is velocity equals to 0, but we still put it in. So use one junction for the distinct velocities. Number 3, attach the elements that move at those velocities. So attach So we have in here the elements, we need to attach them. Let's just go over here and we'll just do this. This is a next to dot. In here we have the I element with M like this. Yeah. In between the car and the seat belt, the car and the dummy is the seat belt. So I can actually do this. Now it actually comes from x sub 2 dot. So let's just start it correctly here. So x1 dot, and then this x2 dot, and the difference between these two okay, so we have this x of 1, x of 2, and then we attach the element for x of 1, which would be the I element with modulus big M. This was with lowercase m. And then this 2, in this particular case, source of flow with velocity equals to 0. So what we need is the difference between this and this to well, to do the difference. But I mean, right now we attach the elements that move at those velocities. So number 4 is going to be, oh, let's just do number 4 is going to be use 0 junctions to represent use 0 junctions to represent the velocity differences. 5. So let's recognize the velocity differences. So x1 minus x2 is the 0. So let's finish that step because we are in the middle of it. So this is the difference between those two is 1, which is x1 dot minus x2 dot. The difference. This one, if you have it like this too, so that's velocity difference. So we have done number 4. Number 5, I would say do attach, oh, number 5. Attach the elements that experience those velocity differences. All right. So we are in this situation. You see, pretty soon it's taking body this, and this in the one that sees the difference is between this and the person, which is this minus this, produce this relative velocity of the vehicle minus the velocity um, of the car. I mean, the velocity of the person is what I mean. Person and vehicle is what we need to analyze. So in here, this value is going to be changed to a C. Um, and then the R element. So C and the R element are this. Yeah. And so is the other seat belt. The other seat belt also contains those elements. So this is going to be C, and then this is going to be R. And we are done. I'm just going to put the step number 6. I would say options. All right. So optimal simplification. And then you will say check causal marks. Causal marks. Check causal marks. I would say make sure power law is correct, because then we'll get different results if it doesn't. So as it is right now, this model can be entered into the ChemG software, and that is exactly what I'm going to do next. Any questions? No? So why don't we go over here and we call the ChemG software and we say, okay, do this. And then we say, okay, do new. Let's just put it in the in terms that we can do this. Or maybe what we need to do is to reduce this too. There you go. This is what we're working over. So we're working with, I want to say. Okay. Mm, all right. So we have the bone graft model on this one. This screen. We're gonna go over here, and then we need to transfer this the bone graft model from the picture on the left hand side to the one on the right. So okay. So let's move in here. We could start it anywhere, as I said. We're gonna go to the one junction here, and I'll just build the I element over here to begin with, and then I will go to the 0 and build that one, and then I can do a 1 and build this C element in here, and then we have an R element, and then you have a 1 junction here, and then an I element, which we could do here. Yeah. So, and then I'll build the 1 over here, the 0, and then we want a 1, let's see, and then we need the R element. There we go. We're almost done. We have one more, and that is over here. And then we have the SF, which is like this. This finishes entering the bone graft model that we had written on paper onto the CAMG software. And you could build it in different ways. You could lay out the zeros first if you want, and the ones. This one doesn't need the steps. The steps are to generate the model on paper. So here you could build the model not only with the the sequential method, as I call it for this, but you could also do the layout first and then the way. I think it might be a good idea to do that so that you can see you have this option. For example, what I would do in that case is we have an option in here where first we are gonna lay out the elements. Like for example, here we have um, one, and then we are gonna put a 0. See here. Then we'll put the other one here. So I'm just laying out the structure first, and then you can do the bonds later. So you have in here, and then we can have from here the 0 like that, and then you have the 1 like this. And so you can connect this, and here you need the I, and on the other one we need an R. Okay, so where do we have this? We put the R element and we put the C element over here, and then we can put the other I element up here. Then finally the SF, I think it is, and we could just build the now we're still missing something. See, this is just a method of doing things, and then do the bonds at the end. You can do it this way because it automatically, you could do it like this, see? And then very quickly get the structure done. The computer assigns the causal marks automatically, so you don't have to do that yourself on paper, but it's good to do it so you can test it. And this is coming pretty good. And now obviously there is a problem. What did I do? There is a problem because in here, you see this is a path that is all in red. And if you ask the program to explain to you, it would actually tell you what it is. But we need to finish this model here. Let me just go ahead and move it up a little bit. All right. And here, this is not a one, but an I. So let's just do delete, and then just put the 1 where it belongs to, I mean the I, and then you have it. So we have built the model in a different way, but still is done the way we need it to.